In this lesson, we're going to continue our study on dividing radicals, but in particular, the radicals that you're going to see in this lesson will require that we use the idea of conjugates. So, for example, remember in previous lesson, we had this situation. So in the previous lesson, you wanted to divide, and let's say we had 3 divided by the square root of 5, okay? And so remember, if you look at your denominator right now, the denominator is an irrational number. So what you're asked to do when you divide this is to make this, is to rationalize the denominator, meaning that you want the denominator to be a rational number. So what we did to get this denominator to be rational and not irrational was that we just went ahead and we multiplied both the numerator and the denominator by the square root of 5. And remember, what you do to the denominator, you do to the numerator, because you remember you need whatever product you write here, it still has to be a factor of 1. So whatever you have in your denominator, you need to have in your numerator. So that way this product is still equivalent to this, because remember you have an equal sign here. So this has to be the same thing as this, and it is, because that's a 1. Now, when we multiply the numerators out, we get 3 times the square root of 5 divided by, and then the square root of 5 times the square root of 5 is the square root of 25, which is just 5. And so that's what we did. But the situation becomes this now. What if I had, let's say, 2 divided by 3 plus the square root of 5? Let's say I had that. So see, now I have a binomial, or I should say I have a expression with 2 terms, right? So I have 2 terms here. And then here I only had 1 term. So here I have 2 terms. So how do I deal with 2 terms? Do I just multiply the numerator and denominator by the square root of 5? No, because look, if you multiply both numerator and denominator by the square root of 5, if you look at this, it's not going to work, because watch. The denominator, if you look at the denominator, 3, so these 2 terms times this 1 term, you use a distributive property. So I get a square root of 5 times 3 plus the square root of 5. And notice what happens is that you get 3 square root of 5 plus, and then the square root of 5 times the square root of 5 is 5. So notice you still have a square root in the denominator. So you still have this. So the denominator is still irrational. So that didn't work, right? So that doesn't work. So then we got to come up with an idea. Well, what can I do? What can I multiply this denominator and numerator by, so that way I can get a rational number in the denominator? Okay, so that's going to be the idea of the conjugate. Okay, so listen carefully to this. Okay, so notice that the denominator here contained a radical, right? Okay, so the conjugate, C-O-N-J-U-G-A-T-E, so the conjugate of an expression such as 6 plus the square root of 3, the conjugate of 6 plus the square root of 3, where you have 2 terms with 1 or both being a square root, is 6 minus the square root of 3. So all you basically do is you just change the sign in the middle. So addition becomes subtraction. Okay, so for example, the conjugate of 4 minus the square root of 7 is 4 plus the square root of 7. Okay, you see, all you do is just changing the sign in the middle. The conjugate of, let's say, the square root of 6 plus 5 is square root of 6 minus 5. See the pattern? The conjugate of the square root of 3 plus the square root of 2 is square root of 3 minus square root of 2. All right, so you notice the pattern, right? Okay. So it turns out that whenever you multiply two binomial radicals that are conjugates of each other, you're going to end up with an expression not containing a radical. Okay, so the expression will have no radicals when you multiply two binomial radicals that are conjugates of each other. They have to be conjugates. So they're conjugates if the sign changes in the middle, okay? And then you're going to end up with a product that has no radicals in it, no square roots. All right, so for example, if I look at let's say the first one here. So 6 plus the square root of 3 times 6 minus the square root of 3. And if I use the FOIL method on this, 6 times 6 is 36. The outer, remember they're conjugates, so it kind of brings us back to when we multiplied a minus b times a plus b. Remember that? So where we had the terms were in the same order, but one sign was negative, one sign was positive, and so when I multiplied out, it ended up with the difference of two squares. So remember that? So what happened was the outer and the inner added to be 0, and so you would just get a squared minus b squared. So the difference of two squares. So the difference of two squares. Same thing applies here. You have that same form here. So if you look at the outer and the inner should be opposites. Now, if you need to write it out, you write it out. There's nothing wrong with writing it out. So notice I get 6 times a negative square root of 3 is a negative 6 square root of 3. A positive square root of 3 times 6 is a positive 6 square root of 3. And then notice what I have here. And it may help if you write this part out as well. A positive 3 times a negative 3 is a negative square root of 9, right? 3 times 3 is 9. Okay? And then notice this right here is 0. Those are opposites. And whenever you multiply two binomials that contain radicals, the outer and the inner will always add up to be 0, just like it did when you talked about polynomials in a previous lesson. Okay, so basically all you have then would be 36 minus, right here, minus, and the square root of 9 is 3, so you get 33. So again, notice what we said earlier. Whenever you multiply two binomials that are conjugates of each other, and notice we are dealing with square roots, and they contain at least one square root, you're going to end up with an expression that does not contain a square root. Okay? All right, so we just said was this. If you multiply two binomial radical expressions, so we have, let's look at the one we're just looking at. So we have a binomial radical expression. We have a binomial radical expression. They're conjugates of each other. What we're saying is that the product, so when you multiply the product, you're going to end up with an expression, an answer, that has no radicals in it. Okay? And so that's what we're going to use. That's the idea that we're going to use to rationalize this denominator, to get rid of that square root that's in the denominator. We're going to use the idea of conjugates. All right. Now, before we actually go back and look at this problem or a problem similar to that, let's multiply another binomial and its conjugate. So let's do one with two square roots in it, because you're going to have that in a little while. So let's look at this one. So basically this statement says this. This statement says that if I multiply these two binomials that are conjugates of each other, I will end up with an expression that has no square roots in it. Okay? All right. So for example, let's actually multiply these out. And then in the process, I want to talk about this. So remember, if the first terms are alike and the last terms are alike except for the signs, the outer and the inner will always have to be 0. So all you're doing is just taking 6 and squaring it, and then taking the square root of 3 and squaring it. So you get 3. Okay? So that's all you're doing. So I'm going to probably use this idea here as well. when I get to that point. So you'll see what I'm talking about. So let's go back and actually multiply this out and see what we get. So let's multiply these two binomials that are conjugates of each other. So I have the square root of 3 plus 2 plus the square root of 2 times the square root of 3 minus the square root of 2. Okay? All right. So, and you're going to have to do this in a little while as well. So remember FOIL. First times first. So remember when I have a minus b times a plus b, then remember that's equal to a squared minus b squared. So the outer and the inner add up to be 0. So all you really get is this. So you can use this idea here. So you notice that the first terms are identical. The second terms are just opposites of each other. So that means if I FOIL that out, the outer and the inner will add up to be 0. So all I'm doing then is just taking the square root of 3 and squaring it, and then minus the square root of 2 and squaring it. So that's what this says. And so the square root of 3 times itself is 3, and the square root of 2 times itself is 2. So all you get is 1 here. 3 minus 2 is 1. And that's all you get. So notice that when I multiplied these two binomials that were conjugates of each other, and they had square roots in it, I ended up with an expression that did not have a square root any longer. Now, if you get a little confused as to multiplying this out using this idea, then actually do it the long way. So in other words, what I'm saying is there's nothing wrong with you actually doing FOIL, actually doing all parts of FOIL. So meaning this, the square root of 3 times the square root of 3, right? Write it out if you need to. Nothing wrong with that. The outer, so this was a first right here. The outer, I have, remember the positive times the negative is a negative. So I have the square root of 3 times the square root of 2, right? And then the inner, a positive times a positive is a positive. The square root of 2 times the square root of 3. And then the last, a positive times a negative is a negative. So remember when you had the first terms identical and the last terms opposites, this is always going to be a subtraction right here because a positive times a negative is a negative. So that's why you see that here. Okay, so then that's the square root of 2 times the square root of 2. So multiplying the last together. And then just use the product rule now. The square root of 3 times the square root of 3 is the square root of 9. The square root of 3 times the square root of 2 is the square root of 6. Plus the square root of 2 times the square root of 3 is the square root of 6. Minus, and the square root of 2 times the square root of 2 is the square root of 4, right? And then notice this is a perfect square, so that's going to be 3. These add up to be 0. They are opposites. And then minus the square root of 4 is 2. And so notice you get the same thing, right? You get the same thing. And so you get 1. All right? So that's what we get when we multiply conjugates, and that's what we're going to use. That is what we're going to use for these problems when we divide radicals in which the denominator has 2 terms. Okay? All right, so if the denominator has 1 term, it's easy. If the denominator has 2 terms, what are you going to use? You're going to use conjugates. So let's see how it plays out. So let's look at this. So this is going to be number 1. So the directions will say divide. It may also say this, but it may not. Okay? So it may also say rationalize the denominator. All right? And so you have to know that, for example, number 1, if we have 2 divided by 3 plus the square root of 5, you have to know that since this denominator contains 2 terms, and one of them is a square root, then the best way, or the way that we need to approach this is to, I'm going to rewrite this over, is to multiply the numerator and the denominator by the conjugate of the denominator. So what is the conjugate of 3 plus the square root of 5? 3 minus the square root of 5. And again, what I do to the denominator, I do to the numerator, right? Because I need, see, this right here still has to equal, or this still has to equal this. And it does, because if you look at this right here that I'm boxing off, that's a 1. Any expression divided by itself is 1. So this expression times 1 is still this. You see that? Okay. Now, you got to do some work now. There's some work involved. So let's look at the denominator. So the denominator are conjugates, right? The denominator are conjugates. So I want you to get into the idea that since those are conjugates, you just take the first, square it, and take the second, square it. All right, now if you got to do it the long way, you do it the long way, and meaning that you write out all of those four terms. But the out and the inner will always be 0. So if I go and I do some work on the side, so let's look at the denominator. So I have 3 plus the square root of 5 times 3 minus the square root of 5, right? Okay, so we're going to multiply that out. We have two binomials that we're multiplying together. So the first times the first, so 3 times 3 is 9, right? The outer and the inner add up to be 0. Those are conjugates. A positive times a negative is a negative, and then I have the square root of 5 times the square root of 5. Y'all agree? And so I get 9 minus, and then remember, most of you know that the square root of 5 times the square root of 5 is 5. If you need to, multiply it out. Use the product rule. That's the square root of 25, and the square root of 25 is 5. And so I get 9 minus 5 is 4. And so notice that's my denominator. So notice that when I multiply a binomial that contains a radical by its conjugate, I end up with an expression that contains no square root in this case. Now look at the numerator though. So I need a numerator here. So the numerator, let's see what we have. We have this. We have 2 times 3 minus the square root of 5, right? 2 times 3 minus the square root of 5. And then you can leave your answer like this, or you can distribute. Oh, I'm sorry. We can reduce, right? So we can reduce this. So let's go ahead and reduce. So 2 divided into 2 is 1. 2 divided into 4 is 2. So the answer then will be 3 minus the square root of 5 divided by 2. Okay? So yeah, so always make sure that you reduce if you can. And so that's the answer. So that's number 1. So notice I rationalized the denominator. So notice the denominator in the answer no longer has a square root in it. Okay? All right, let's look at number 2. So it's really not that bad. You just got to know that first of all you have to multiply both numerator and denominator with a conjugate, and then do your work. Just some work that you have to do using FOIL. Okay, number 2. Let's suppose we had this. 3 divided by the square root of 7 minus 2. So 3 divided by the square root of 7 minus 2. So notice I have a binomial. So multiplying, like we did here, the numerator and the denominator by the square root of 5 doesn't work. You saw that, right? Because you still have a square root in the denominator. So multiplying numerator and denominator by the square root of 7 is not going to work. You got to remember this. Whenever you have a binomial and there is a square root in the denominator, to rationalize that denominator, to make that denominator no longer have a square root, we have to use the conjugate. So what is the conjugate of square root of 7 minus 2? So the conjugate of the square root of 7 minus 2 is the square root of 7 plus 2. And so that will guarantee, when I multiply these together, that will guarantee that the product will not contain a radical. Okay? But what I do to the denominator, I have to do to the numerator. All right, now let's go off to the side and actually do the product. Actually, let's multiply those two binomials together. So I have the square root of 7 minus 2 times the square root of 7 plus 2. Now remember, whenever you multiply two binomials or conjugates of each other, the outer and the inner are opposites. So if you look at the outer, that's 2 squared root of 7. This is a negative 2 squared root of 7. Okay? So all you really get is the first times the first, and then the last right here. So I get the square root of 7 times the square root of 7. A negative times a positive is a negative, and so notice I get negative 2 times a positive 2, which is a negative 4, correct? And then you all know what the square root of 7 is. That's just square root of 49, which is 7. So I get 7 minus 4, which is 3. And so notice my denominator is just 3. Okay? And then if I look at the numerator, So I have this monomial times this binomial, so I get this, right? So write it out like that so far at this point. And then notice that these threes divide out. Now, it's not going to, in 1 and 2, I was able to reduce. It's not always going to be that way. It just happened to be in the first two examples. So I reduce if you can, and so I get just the answer is square root of 7 plus 2. And so that's the answer. So notice that the denominator was a 1. It did not contain a square root. Okay? All right, let's look at number 3. So number 3, we have, all right, so number 3, we have this problem. We have the square root of 5 divided by 2 plus the square root of 7. All right, so notice that I need to rationalize the denominator, so I don't want a square root in the denominator, so that's the idea of that rationalization. But it is a binomial, so to get rid of that square root, I've got to, I'm going to rewrite this over, so I've got to multiply both numerator and denominator by the conjugate of the denominator. So what's the conjugate of 2 plus the square root of 7? 2 minus the square root of 7. But what I do to the denominator, I do to the numerator. And so then I do the work in the denominator. So I multiply those denominators out, which is easy. Okay, very easy. The outer and the inner will add up to be 0. You can even see those are opposites, a negative 2 squared root of 7, a positive 2 squared root of 7. That's always going to be the case when you're dealing with conjugates, when you're multiplying two binomials that are conjugates of each other. So all you're really looking at is the first and the last. So 2 times 2 is 4. A positive times a negative, it's always going to be that way. Positive times a negative is a negative. And then we have the square root of 7 times the square root of 7. Write it out if you need to. And so this becomes 4 minus, and then the square root of 7, square root of 7 is square root of 49, which is 7. So this becomes a negative 3. So my denominator is a negative 3. Okay? My numerator, I have this. I have the square root of 5 times 2 minus the square root of 7. Okay? Now let's go ahead and multiply this out. So notice I can't reduce anything here because that's the square root of 5 and that's just negative 3. So let's go ahead and distribute. So I'm going to get 2 square root of 5 minus, and then remember I'm going to write it out. I have the square root of 5 times square root of 7, right? Divide by negative 3, but I expect you to go with this further. So you could have skipped that step, and some of you could have seen that hey, I'm multiplying square root of 5 by the square root of 7, so that's the square root of 35. So the answer is going to be 2 square root of 5 minus square root of 35 divided by negative 3. And then if you can't simplify the radicals, then go ahead and simplify. But I cannot simplify the square root of 35, and I cannot simplify the square root of 5. So that's it. That's your answer. Okay? All right. Now, let's go ahead and look at number 4. So in the end, you'll notice that when you're rationalizing the denominator, when you're dividing radicals, at this point, yeah, go ahead and distribute and then write it without the parentheses. So you don't want any parentheses here. All right. Number 4, we have the square root of 3 divided by the square root of 2 plus the square root of 6. The square root of 3 divided by the square root of 2 plus the square root of 6. All right, so it kind of looks like that one, right? Except the denominator here has 2 square roots, and the denominator here only had 1. Okay, no big deal. We can still handle that, right? So you're still going to want to make sure that your final answer does not have any square roots in the denominator. So to do that, since this is a binomial, all I'm going to do is multiply the numerator and the denominator, by the conjugate of the denominator. That's supposed to be a 6. So what is the conjugate of the square root of 2 plus the square root of 6? Okay, the square root of 2 minus the square root of 6. But what I do to the denominator, I do to the numerator. Okay, because this right here still has to equal this. And it is because that's a 1 right here. Okay, so here we go. So we go off to the side and we do the work just like we did here. So I have the square root of 2 plus the square root of 6 times its conjugate. And remember, as we said, when we use the fold method, the outer and the inner are opposites. And you can see that's true because look at the inner. The square root of 6 times the square root of 2 is the square root of 12. And the outer is the same thing, except opposite. Square root of 2 and square root of 6 is square root of 12, but it's a negative square root of 12, so when you add them up, you get 0. It's always going to be that way. So all you're looking at is the first and the last. So write it out. You're going to say the square root of 2 times the square root of 2. If you need to write it like this, you write it like this. Positive times negative is a negative. So you're subtracting. The square root of 6 times the square root of 6. You see that? Square root of 6 times the square root of 6. And so the square root of 2 times the square root of 2 is the square root of 4, which is 2, minus the square root of 6 times the square root of 6 is the square root of 36, which is 6. And so I get 2 minus 6, which is a negative 4. Okay? And so we get this denominator being negative 4. Now the numerator, I have this. So I'm going to go ahead and deal with the numerator right here. So the numerator, let's do the numerator here. So the numerator is the square root of 3 times the square root of 2 minus the square root of 6. Okay? And so when I distribute, I get the square root of 3 times the square root of 2 is the square root of 6 minus, and then the square root of 3 times the square root of 6 is the square root of 18, right? Okay, now remember what we said. If you can simplify the radicals, you go ahead and do that. So I can simplify the square root of 18. That's important. You have to do that if you can. Okay, so you have to still simplify. So make sure you simplify just like you've done before. So this, I get the square root of 6 minus, and then the square root of 18 is the square root of 9 times 2. And so this becomes the square root of 6 minus the square root of 9, square root of 2, right? And so I get the square root of 6 minus 3, square root of 2. And so that's the numerator. So that's going to go here. So the square root of 6 minus 3, square root of 2. So it's very important that you learn, that you use everything you've learned with everything you deal with current and in the future. So notice that when I multiplied this, the square root of 5 times this binomial, and I distributed, I couldn't go any further because the square root of 35 I could not simplify, and the square root of 5 I could not simplify. Okay? When I got to this point here, and I multiplied the numerators using the distributive property, the square root of 3 times square root of 2 square root of 6, square root of 3 times square root of 6 square root of 18, and I notice I can still simplify the square root of 18, just like I've done before. So now this is your numerator. Okay? Now let me just say this. See how I have a negative in the denominator? You could, if you wanted to, written it like this. You could have said negative, and then your fraction would be just the numerator, square root of 6 minus 3 square root of 2 divided by the denominator. So this means the same thing as this, just as long as you have that negative in front. You see how it looks? The negative symbol's in front of that fraction right here. Okay? All right. And I could have done the same thing here, right here. So if I wanted to, I could have said negative and then 2 square root of 5 minus square root of 35 divided by 3. As long as that negative is in front of that fraction. So you make it look like it's in front. Don't make it look like it's still part of this term right here, because then that's now incorrect. Okay? All right, now let's look at number 5. So it's really not that bad, just multiplying by the conjugate. There's just a little bit of work using a flow method and then simplifying if you can, but it's really not that bad. Okay, number 5. Let's suppose we had this for number 5. We have the square root of 3 plus 2 divided by 5 minus the square root of 2. Okay? All right, so again, I don't want a square root in the denominator. It's okay if I have in the numerator. I just don't want a square root in the denominator. So that's why we say rationalize the denominator. And so what I'm going to do is I'm going to multiply both the numerator and the denominator by the conjugate of the denominator. And that will guarantee that my final answer will no longer have a square root in the denominator. Okay? So what is the conjugate of 5 minus the square root of 2, 5 plus the square root of 2. What I do to the denominator, I do to the numerator, because this has to still be a fraction of 1. Okay, now, notice this time I have 2 binomials in the numerator and 2 binomials in the denominator. So I'm going to use a FOIL with both. Okay, always start with the denominator because that's the easiest to deal with. And the reason is because those are conjugates. So that means that when you use the FOIL method, the outer and the inner add up to be 0. Those are opposites. And so really all you have to do is look at the first and look at the last. So I get 5 times 5 is 25. A negative times a positive is a negative. And then the square root of 2 times square root of 2. And so I get 25 minus, and that's going to be square root of 2. Square root of 2 is square root of 4, which is just 2. So I get 23. So that is my denominator. So notice I no longer have a square root in the denominator. Now look at the numerator. Now be careful. Be careful. Don't overgeneralize here. So some students get so caught up in the fact that the outer and the inner add up to be 0 that they think the same thing is true here. It's not. Are those conjugates? Those are not conjugates. So you will have 4 terms. First, outer, inner, last. And the outer and the inner will not add up to be 0. The only way the outer and the inner add up to be 0 is if those are conjugates. And those are not conjugates, okay? So you got to be careful. So let's look at the first. So I have the square root of 3 times 5 is 5 square root of 3. The outer, the square root of 3 times the square root of 2 is the square root of 6. The inner, 2 times 5 is 10. So you see the outer and the inner are not the same, or are not opposites, excuse me. And then the last, so that was the inner. The last, I have a positive 2, so a positive times a positive is a positive. And so I get 2 square root of 2. Now notice that none of these are like terms. None are like terms. And I can't simplify any of it. Okay? Square root of 3, I cannot simplify. Square root of 6, I cannot simplify. Square root of 2, I cannot simplify. There's your answer. That is your numerator. So yeah, so sometimes your numerator will have 4 terms in it. Sometimes your numerator will have 2 terms in it. Okay? So I get, I may not have enough room to write all this, so I'm going to write small. You get 5 square root of 3 plus the square root of 6 plus 10 plus 2 square root of 2. And it doesn't matter in what order you put these terms. Okay? All right, so that's it. So you see how do you do this? All right, let's look at number 6. Number 6, we have, let's do another one like we just did. So let's say we have 3 minus the square root of 2 divided by the square root of 3 minus the square root of 5. All right. So again, I need to make sure that the denominator is rationalized, meaning that I don't want a square root in the denominator. I want my denominator to be a rational number. So notice that this is a rational number. This is a rational number. Negative 4 is a rational number. Negative 3 is a rational number. 3 is a rational number. 2 is a rational number. Okay? So you want to rationalize the denominator. So the only way I can rationalize that denominator is to multiply the numerator and denominator by the conjugate of the denominator. Okay, so I'm going to get 3 minus square root of 2, and then the denominator is square root of 3 minus square root of 5, so multiply both numerator and denominator by the conjugate. Okay, by the conjugate. And that will guarantee that the denominator, when I multiply it out, that will guarantee that this is going to be a rational number. All right, and it will be. So watch. The square root of 3 minus square root of 5 times square root of 3 plus the square root of 5. And so notice the outer is the square root of 15. The inner is negative square root of 15. So just like we said, those have to be 0. So all you're really looking at is the first and the last. And so if you look at the first, I have the square root of 3 times square root of 3. And then a positive times a negative times a positive is a negative. And then the square root of 5 times square root of 5, right? And so I get square root of 3 times square root of 3 is square root of 9, which is 3, minus. And then that's square root of 5, right? Because the square root of 5 times square root of 5 is the square root of 25, which is 5. And so 3 minus 2 is a negative 2. So that's your denominator. So notice I have a rational number now, no square root. Okay? All right, now let's go ahead and multiply the numerators. Now notice those are binomials, so you're going to have a little bit more work to do. So I have 3 minus square root of 2 times, that's supposed to be a 3 right here, sorry. Oh no, I'm sorry. Square root of 3, excuse me. And then the square root of 3 plus the square root of 5. Okay, so let's multiply those out. So notice those are not conjugates, so you will have an out and an inner to deal with. Okay, so first, I have 3 times the square root of 3. The outer, I have 3 times the square root of 5. A positive times positive is positive, so 3 square root of 5. The inner, a negative times a positive is a negative, but notice, look, I have the square root of 2 times the square root of 3. That's the square root of 6. And then the last, a negative times a positive, so that's the inner. And then the last, a negative times a positive is a negative. And then the square root of 2 times the square root of 5 is the square root of 10. Okay? Now, here's the question to make sure I did this correct. So 3 square root of 5. So the first, so I'm sorry, that was a 3, right? So that should be 3 square root of 3, correct? All right, so be careful, be careful. Always go back and double check your work. So the first, 3 square root of 3. Let me make sure I wrote this correct. Yep, okay. And then the outer is this, that's correct. The inner is this, and then the last is that. Okay, now are any of those like terms? Nope, none of them like terms, right? That's a 3 right here, square root of 3. They are simplified, and so there's your answer. There's a numerator. So the numerator is going to be 3 square root of 3 plus 3 square root of 5 minus square root of 6 minus square root of 10. All right, and it's okay to have the denominator be negative. Leave it like that so you don't kind of mess things up. Okay, whichever is correct, leave it. Okay, so that was number 6. Let's do 2 more, and then number 7. Okay, so when we look at number 7, I want to show you something that's different with number 7. So number 7, we have 6 divided by 2 minus the square root of x. So notice that in all the previous problems we've done, all 6, we didn't have any variables. Okay, all those terms were real numbers. Okay, now we have a variable expression now. So do the same thing. So if I want to get rid of that square root, then I'm going to multiply. I'm going to multiply the numerator and denominator by the conjugate. Same idea. No big deal. You can still use the idea of conjugates with variable expressions. So what is the conjugate of 2 minus the square root of x? 2 plus the square root of x. And then what I do to the denominator, I do to the numerator, right? And so now let's go ahead and multiply the denominators out. So I get 2 minus the square root of x times its conjugate, 2 plus the square root of x. And so when I use the follow method, remember the outer and the inner will add up to be 0, and they do, because notice 2 square root of x and a negative 2 square root of x is 0. And so all you're looking at is the first and the last. That's all you're looking at. And so when I write out the first, the product of the first, I get 2 times 2, right? And then a negative times a positive is a negative. Notice when you deal with conjugates, this is always subtraction. And then you have the square root of x times the square root of x, right? Okay, so 2 times 2 is 4 minus. But what's the square root of x times the square root of x? Is the square root of x squared, right? And what's the square root of x squared? It's just x. So what times itself is x squared? X. And so there's your expression. So notice the difference between the previous 6 and this one is that in both cases, you don't have square roots any longer in the denominator. You see that. In the previous 6, though, those were actual right here. When you go back to your denominators, those were actual rational numbers. Okay, didn't have any variables. Here, though, this 4 minus x is not a number. It's a variable expression. But we still rationalize the denominator in the sense that I no longer have square root. Okay. All right. Now all I got to do now is just multiply the numerators together. So let's go ahead and do that here. So I have 6 times 2 plus the square root of 6, and then go ahead and distribute. So 2 times 6 is 12. It will actually be a little bit careful. So remember in one of the previous problems we saw that we can reduce right here. So what I would do when you have a monomial right here is I would actually write it out first. like this, and then see if you can reduce, and I cannot reduce. Now don't say the 4 and the 6, okay, because 4 is not a factor. 4 minus x is a factor in the denominator. All right, so you got to be careful. Some students want to reduce these two, and mathematically that's not correct. So I can't reduce, and then you just multiply. So when I multiply, I'm going to get 6 times 2 is 12, plus, and then 6 times the square root is 6. And just put that in the numerator. So you get 12 plus 6 squared is 6 divided by 4 minus x. Now, I'll be honest with you, depending on the textbooks, some will say you can leave it like this, and some will say multiply. It does not matter, okay? It's just that when you're dealing with dividing radicals, just go ahead and write your answers without the parentheses, without any parentheses in it. But if you leave it like this, that's fine, okay? The problem is, though, that when you get to this part here, where we had to, at some point, right, see right here, where we could have simplified, you need to be careful. So I would just go ahead and distribute. I would get rid of the parentheses and not have parentheses in my final answer. Okay? All right, so number 8. So that part's a little confusing because some will say leave it with parentheses, some will say go in and get rid of the parentheses using either FOIL or distributive property. So let's just go ahead and get rid of the parentheses. So number 8, we have 3 divided by the square root of x plus 4. And so the conjugate, see, you have a variable expression, so the conjugate of the denominator is the square root of x minus 4. So it's going to multiply the numerator and the denominator by the conjugate. And so since I'm multiplying the square root of x plus 4 by its conjugate, I will no longer have a square root in the denominator. I'm going to end up with a radical expression because I have variables here, but I will not have a square root. So let's go to multiply it out. Square root of x plus 4, square root of x minus 4. And so when I FOIL, and remember the out and the in are 0, they have to be 0. So when I look at the first and the last, I get the square root of x times the square root of x, right? And the last, a positive times a negative is a negative, and so I get 4 times 4, which is 16. And so here, the square root of x times the square root of x, we know is square root of x squared. We already dealt with that, so that's just x. So we get x minus 16. So that's your denominator. So notice that I no longer have a square root in the denominator. Now my numerator, I have 3 times the square root of x minus 4. And so let's go ahead and distribute. I cannot reduce anything here. So let's go ahead and distribute. So I get 3 square root of x minus, and then 3 times 4 is 12, divided by x minus 16. And so that's it. Okay, so that is our study on, if I can find the first page. So that is our study on rationalizing dividing radicals by using the idea of conjugates. All right, so that's the end of this lesson.